9 is 145. Are we good on that first part of homework? All right. Let's look at this part of homework, 11 and 13. We had f of x equals 1/2 x minus 7 and g of x equals x plus 6. And we want to find f of g of x. X is closest to g. So g of x equals x plus 6. You take what's inside that parentheses, plug it in. I took x, I plugged it in, did it change it? No. So now I'm going to take this, plug in the f. My f function is 1/2 x minus 7. I take it, I plug it in, distribute the 1/2, and I get 1/2 x minus 4. Then I have g of f of x. Take x close to f, plug it in, I get the same thing, now plug in the g, and I get 1/2 x minus 1. So those are my two answers for number 11. Are there any questions on number 11? All right, number 13, we have an L function of 2x. We have the g function x cubed plus x squared plus 1. And we have f of g of x. I take x, I plug it in g, it stays the same. Now I take that and I plug it in to f and I distribute the 2 and I get 2x cubed plus 2x squared plus 2. Okay, then I got g of f of x. Take x, I plug it into f, I get 2x. Now I take that, plug that into g. Be careful with your exponents here. So 2x cubed is 8x cubed. 2x squared is 4x squared plus 1. So my answer is 8x cubed plus 4x squared plus 1 for g of f of x. Yes?
Okay, so like neither of those could, but if it could be factored?
You only factor when you have a quadratic equation. And we're not solving a quadratic. That's a good question. I always just think the only time you factor is when it's equal to 0, quadratic. When it's got an equal sign. How we feel on homework? Feel all right? Tonight, your homework's going to come off the same, but I know that looks like a lot, but that's 10 problems for homework. 10. That's all it is. 10. I counted them. All right, so, but part of your homework comes off this same page tonight. Tonight is 14 through 16. So I just want us to look at this. On 14, now on 15 and 16, you just got to find one of them, f of g. But 14, you still got to do f of g and g of f. But let's make sure we understand this. If I got on this particular one, g of f of x. X is closest to f, isn't it? Please watch me. X is closest to f, so I will get this, got that, that stays same. Now I got to plug that back in here. When I plug that back in, will I have to do the FOIL method? Yes, please don't forget that. Please don't, okay? Are there any questions? Okay. Now turn to page 75 for our notes for today. So 14, 15, 16 is off that page for homework. Couple announcements. Forget about this. Tomorrow, math team will meet in 0 period in Miss Tetstone's room. So that means on Tuesday now I won't have 0 period. I'll be at math team. Okay. So if you need me in 0 period, Monday, Wednesday, Thursday, Friday. But on Tuesdays in 0 period, I'll do math team. If you're in Leo Club, if you turned your form in, Leo Club, the first meeting for Leo Club, it should be on the announcements. Okay, Leo Club's got really large this year. So we're going to have 2 separate meetings. Seniors and juniors will meet together. Sophomores and freshmen will meet together. Okay. So the senior and juniors meeting is next Thursday, September 27th, in the Innovation Center during 0 period. Okay. So I want to put that on your calendar if you're in the Leo Club. That meeting is September 27th, 0 period, Innovation Center. We have 2 meetings a semester. That's one of them. The other one will be in November. And the rest of the time, like in October and December, we communicate during Google Classroom. What else did I tell you? test Wednesday. We're going to have some visitors in our classroom Thursday. Just act normal like we always do. That's about it. All right. Anybody got anything they want to share from the weekend? Yes. Mm-hmm. Oh, Lord. Y'all have SGA that Thursday?
I'm not sure. Sometimes the spot room switches it up. I mean, it's always on Thursday, but sometimes it's
You might can make both of them. Okay, we're talking about it.
because she puts hers to 7 to.
Okay, yeah. All right. So our last thing that's on this test is the concept of inverse functions. What do you think inverse functions do? Yeah, that's the root. We're going to solve for some x and y, but what's the underlying concept with inverse? Read the first line. They undo each other. Yes. They undo each other. Just like, what's the inverse of addition? What's the inverse of division? Well, functions have inverses too. So inverse functions undo each other. And for example, let's say we have this function. And I'm going to teach you how to find the inverse in a minute, but I'm going to tell you this is the inverse of that. Now, I want you to notice the notation. That's F with a little -1. It looks like an exponent, but it's not an exponent. It's just sitting there. That lets you know that's the inverse of something, okay? That's the inverse of something. So, let's pick some numbers for x. Just pick me 2 or 3. Give me a number. 1. Okay. 1, 2, 3. If I took 3, what's 3 times 1? Plus 2 is? 2 times 3 is? Plus 2 is? 3 times 3 is? Plus 2 is? 11. What do you think is going to happen over here?
The x and the y values are going to switch.
Correct. Thanks for reading that. I want you to think about it, Richard. All right. So, watch this. Let's see if I take 5 in here. What's 5 minus 2? 3. 3 divided by 3 is? Do you see how they flip? Okay, now let's try 8. 8 minus 2 is? 6 divided by 3 is? And so forth. So you see the relationship there? Your domain and range are swapped in inverse functions, okay? So, inverse functions undo each other. It says if f of g of x equals x and g of f of x equals x, then f and g are inverse functions. That's how you use to prove if something's inverse. You find the f of g and then you find the g of f. And if both of them equal x, that proves they're inverse functions, okay? So that's something that you need to know. It says therefore f of the inverse of f function is equal to what? What do you think happens to this inverse and the regular function? Cancels and is equal to x. So inverse functions switch x and y. Therefore, the domain and range switch. Fun little fact, they're symmetric across y equals x, the identity. It says to find the inverse, switch x and y and then solve for y. We're going to talk about that more a little bit later on. Now, this is a very important one. A function whose inverse is also a function is considered to be 1 to 1. You need to know that. That's the symbol for 1 to 1, or it can be written 1 to 1. In order for a function to have an inverse, it must be 1 to 1. And what 1 to 1 means is this. If you look at it, let's say we look at our table of values, or x and y. How do we determine something's a function? The x's do not what? Repeat. To be 1 to 1, your x's don't repeat and your y's don't repeat. Because if I flip that around, wouldn't my y's be x? So that's basically what you check. You basically check your x's and your y's and to see, make sure none of them repeat. Okay, does that make sense? Now right here, on number 1, it says find the inverse of this function. Okay, my inverse, I just flip it around. 3, 2, 4, 3, 6, 5, 8, 7. Now, it says, is it 1 to 1? Well, first let's check the original. Do any of my x's repeat? No. So is the original function? Is the original function a function? Yes. That's a lot right there. Okay. I should have said original relation. Okay. Look at this next relation. I flipped it around. Do any of my x's repeat?
No.
No. So is it 1 to 1? Yes. It's 1 to 1. Alright. What's my inverse on number 2? 3, 2, 5, 4, and 3 and 6. Alright, let's look at beginning. Was it a function? Yes. Now, let's check the inverse. Is it a function?
No.
So is it 1 to 1? No. Number 3. Let's think of this. I like the situations. When I say name, I mean first and last name. So anybody in here, first and last is going to be the same. In the world, is there any 2 Jackson Nolans that look like? Oh my God! Yeah, I'm talking about in this room. In this room. No. Okay. So is it a function to begin with? Yes. But if I turn that around, can somebody have the same height? So is that 1 to 1? No. All right. We're going to skip this one right here and go to these because it's the same thing. Now, it says, how could we tell by looking at the original function, is it 1 to 1? What was that test we used to tell if something was a function? Vertical, okay? Guess what? There's another test. Horizontal was for 1 to 1, okay? So you got vertical to determine it's a function. So if it passes the vertical and the horizontal, it's 1 to 1. So looking at this, that first one, would it pass a horizontal line test? Yes, it would pass. I don't know why one's blank here, but next one. Would that pass? Yes. How about this? No. It's a function, but it's not 1 to 1. How about this one? Yes. How about this one? Yes. Okay. So on your test, when you see, I could give you a table, or I could give you a graph. And I'm going to say, is it 1 to 1? So you would have to say yes or no, explain why. If it was a graph, you put it doesn't pass the, or it doesn't or does pass the what test? Horizontal. If I gave you a table, you would say the x values do not repeat in either the original or if I did the inverse. Okay? Or you could just say that none of the x or what? Y's repeat. That's fine too. Okay? Are we good with that? Okay. So in order to be an inverse, in order for a function to have an inverse, it must be what? 1 to 1. Must be 1 to 1. So our first learning target today, Tyler, read it.
I can determine if 2 functions are inverse.
That's what we're going to work on first. I can determine if 2 functions are inverses, okay? I'm doing these problems, but I put them on notebook paper so you can see them so I have more room to write big, okay? So number 5, we want to determine if these 2 have inverses, if they are inverses. Okay, and what was that rule we talked about at the beginning? We had to do f of what? G of x and then g of what? So that's what you do. You do f of g of x and g of f of x. And what do I want to get at the end of each of these? X. If you say, Mr. What if I did the first one and didn't get x? Then you can just stop because it's not a function. It doesn't have. They're not inverses. Okay, so g. What's closest to g? X. I'm going to do g of x. I plug x in. It does not change. Now I'm going to plug that into f. Can I cross those 2's out?
Yes.
And I'm left with x plus 4 minus 4. The 4's cancel, I'm left with x. So I'm on the right path right now. I got x here, but I got to check this one over here. So I got f of x equals 2x minus 4. Now I'm going to Plug that into G. These negative 4's cancel out. I'm left with 2x over 2, which reduces to x. Are they inverses? Yes. And that's how you prove. I box my x's in. Yeah, you're talking about this one here or over here, Jack?
Yeah.
First one, yeah. The 2's cancel out, and then your 4's cancel out. Why don't you do 6 right now? Go ahead and do 6. Alright, what did y'all come to find? Are they inverses? Yes, they are inverse. So here we go. Let's see why. You have f of g of x. So I got g of x equals the cube root of x plus 5. Now I'm going to plug that into f. What happens to the cube root in that cube? Cancels out, and you got x plus 5 minus 5. Therefore, those cancel out, and you're left with x. And then you have g of f of x. So I got f of x equals x cubed minus 5. Now do g of x cubed minus 5. I got x cubed minus 5. Minus 5 plus 5. Well, those cancel out. And then you take the cube root of x cubed, that would be equal x. So that is why that's yes as well. Are there any questions so far? All right, let's look at number 7. What do you think number 7 is going to be? No, because we ain't done one. So let's see what happens here. F of g. So I got g of x equals 1/2 x minus 1. Now f of 1/2 x minus 1. Distribute 2 times 1/2 x is x. 2 times negative 1 is negative 2. Oh, negative 2 and 1 gives me what? Do you see that? I plugged 1 half x minus 1 into the f function. 2 times 1 half is x, but 2 times negative 1 is negative 2. And then when I get down here, negative 2 plus 1 gives me negative 1, don't it? So did I get x here? So that's why it's no, they are not inverses. Does that make sense to y'all? Okay, f of g of x, x is closest to g. I'm going to plug that in. I get 1 half x minus 1. I take that and plug that into f. 2 times 1 half is x. 2 times negative 1 is negative 2. When I combine negative 2 and 1, they do not go away. You want just x, but I got negative 1. Does that make sense? Are we sleepy this morning? I can tell. Alright, so let's review key points of inverse so far. What do inverse functions do to each other? They what? They undo each other. So if I have my original function, my domain and range, what happens in my inverse? They do what? They swap. In order for a function to have an inverse, it has to be what? What is the term? 1 to 1. And 1 to 1 means that your x's don't repeat and your what don't repeat? Y's. It's a function both ways. Does that make sense? Now, how you doing?
I'm doing great.
How can you look at a graph and tell it's 1 to 1? Passes the what? Horizontal line test. Okay. So now we're going to find some inverses. So let's look at. See, here I tell you that they are inverses. Why do I tell you that the following functions are 1 to 1? Why do I have to tell you that? Because they have to be 1 to 1 to find an inverse, don't I? I don't make you do that first to prove that they're 1 to 1. Alright, so on number 8, we want to know, find what is the inverse of f of x equals 3x minus 4. The first thing I do, guys, is I rewrite that using a y. Y equals 3x minus 4. And there was a word up in the notes that said to find the inverse, switch x and y. So I'm going to switch x and y. X will come over here. Y will come over there. And then what do you think we'll just do? Solve for y. Very good. So I'm going to move that negative 4 over. It's going to be a positive 4. Then I divide by what? 3. And that is my inverse. X plus 4 over 3 equals, use the inverse notation, and that would be my answer. X plus 4 over 3 equals, change the y out with the inverse notation, and that's your answer. Let's do number 9. Okay, I'm going to rewrite f of x as y equals x minus 1 over x plus 2. Now I'm going to swap the position of x and y. Now, I want you to notice this now. We have 2 y's in this problem. Whenever we solve for y and we have 2 of them, what's toolkit strategy sometimes always when we got more than one variable and we just need one, what are we going to end up doing somewhere in the problem? Factoring, okay? I just want you to know that. We have 2 y's and we're going to need 1, so we're going to end up factoring somewhere. So just be thinking about where this is going to take place. So I'm going to cross multiply. X times y plus 2 equals y minus 1. Now I'm going to distribute xy plus 2x equals y minus 1. So what should be our next thing we do here? So you're talking about, okay, you could do 1, 2 things. You could bring this y over here, or you can bring the xy. You just need to get your y's on one side. Now, depending on which one you move, if your neighbor moved one and you move the other one to the other side, you're going to get 2 different answers, but they mean the same thing, okay? They might just look a little different, okay? Like right here, xy plus 2x. I'm going to move the y over here, becomes negative, move the 2x over here. In a minute, I'm going to go back and do it the other way, show you that you get two different, but it's the same thing, okay? Now, here, what can I take out of this? Oh, y. Now, I want to get that y by itself, so I'm going to divide both sides by what? So, there's your inverse. Now, if you would have done this, let's say that I moved my y over here and did this step right here. I did 2x plus 1 equals y minus xy. You still factor out. Both of those are correct. It's essentially the same thing. So if you got that and your neighbor got that, don't freak out because that's the same thing. Because the only difference here, guys, here, this is, you see how they took out, like, okay, how did I get a positive 2? How did I get a positive 1? They factored out a what right there? They factored out a negative 1, didn't they? Okay, so technically those two things are both the same, okay? They just factored out a negative 1. If you were to factor out a negative 1 here, you would get 2x plus 1 over negative x plus 1, and that's the same thing, okay? So I just wanted you to see both ways.
So what's that second one say?
2x plus 1 over 1 minus x. Main thing is when you see two y values, you just want to get one. We've got to use the what strategy? Factoring. All right, the last example for the day. I'm going to let you do that one because it's the easy one. I'll get you started here. Number 10. So you swap your x and y. Now you're going to get y by itself. You're going to move negative 16 over to positive 16. To get rid of that cube, you've got to take the cube root of both sides. So your cube root of x plus 16 is your inverse function. Yes. We officially completed everything that's on your test now. Okay. So let's go back to our learning targets. Our first one. I can determine if two functions are inverses. That means if I did f of g or g of f, they both got to give you what in the end? X. Okay? So I need a hand signal. How do you understand the first one? Good? Alright, now, how are we finding the inverses? I need a hand signal. Sorry. Good, okay, you must start your homework. Promise me y'all be a little more lively tomorrow. Get some sleep. Yes. Talking about what I just said, why? Y's a negative 1 is not being accepted. The other notation. Yeah. You won't see y to the negative 1 in college. tomorrow we're just going to review everything.